our celebration of the 50th birthday of the Department of Computer Science. But not only that, also the 60th birthday of the Canadian Information Processing Society and the 112th birthday of Grace Hopper. And I'm not sure if everybody who's clapping knows who Grace Hopper is, but we'll go into that a little bit later. So let me first start by saying, let me start this event by respectfully acknowledging that University of Regina campuses are located on Treaty 4 and Treaty 6 territories, the ancestral lands of the Cree, the Saulteaux, Dakota, and Lakota nations, and the homeland of the Métis. So let's see if the technology works. Okay. Maybe I should, yes. So what I was going to say is listed somewhat in your program about how in 1970 Larry Symes became the first member of the department and the head of computer science as well. And until 1971, computer science classes were offered by the Faculty of Administration and the Department of Mathematics. This made it a little more difficult to identify who were the first graduates from the Department of Computer Science. So we're still working on that. So in 1973, as director of the Computer Center, Dr. Symes ordered a Xerox Sigma 9, the university's first time-shared computer. So the first graduates from computer science, I'm going to say about 10 of them, convocated in 1973 and 74, spread out across a few different convocations. So from those 10, in this semester we have, oh, there it is, okay. 687 undergraduate students and 163 graduate students, 21 PhD, and 142 master's students. So it's a bit of growth from those first 10. So I wanted to also mention KIPS because the Department of Computer Science has a strong relationship with KIPS over the years. So Brian Mcguire, Alan Law, and Larry Symes were all involved in the leadership of the local KIPS organization. And also Larry Symes was the national president of KIPS. And in 1975, in June of 1975, we hosted the KIPS national meeting. Does anyone remember June 25th of 1975? Got a little bit of rain that day. So Grace Hopper, she's known variously as the mother of computing, but she's also, for almost everybody, she's attached to the phrase, it's easier to ask forgiveness than to get permission. So now you know where that came from. And she also said, please cut off a nanosecond and send it over to me. And I don't think that needs any further explanation. So Computer Science Education Week has been running since about 2010, a little bit before that. It started in the States and now it's an international affair. And so this is from this year's map of activities for Computer Science Education Week. And if you look over there by Regina, there's a little bit of a clearing and you can see some dots. I asked for special status for our birthday party tonight, but I didn't. Somehow they missed the opportunity. So I want to let everyone know that we're still working on some stories and pictures and so forth from the history of the department at this website, UR50CS.uregina.ca. So if you're inclined to look at some pictures there and maybe identify some familiar faces, please do that. and leave me some comments or send some email. And then I wanted to point out the University of Regina Faculty of Science webpage. We have the 50th birthday there, and so we're working. We appreciate your support tonight, and we'd appreciate further support for scholarship and outreach activities that we're undertaking, some of which help to engage Dave Plummer in computing on Saturday mornings here at the university. Anyway, enough introduction. I realize I didn't say who I was. My name's Daryl Hepting. I'm an associate professor in the Department of Computer Science. I did my bachelor's here and my master's in '88 and '91, and then I came back in 2001. So please let me call on Corey Butts, the Associate Dean of Research for the Faculty of Science, to introduce our speaker.
On behalf of Doug Farnick, the Dean of Science, it is my pleasure to welcome our speaker, David Plummer. In 1994, David received a Bachelor of Science, High Honors in Computer Science from the University of Regina. He was born and raised in Regina and now lives in the Seattle area. David worked at Microsoft, where he served as a developer and a development manager on every major operating system from MS-DOS through Server 2003. However, his love for computers began here in the computer labs at the University of Regina on Saturday mornings. Please welcome David.
Thank you. This is actually the wrong slide, so let me back it up. There we go. Good evening, and thanks for having me. Traditionally, for me to do any public speaking would require that somebody die or get married. And so with this being quite literally my first ever attempt at actual public speaking, that obviously means the first thing I did was to Google actual public speaking. And the conventional wisdom seems to be the one should open with a joke of some kind. I don't know if it qualifies as a joke, but I have a little anecdote that I bet will tie in with what's probably your very first questions. I was in Las Vegas once, and at the end of the night, through what I'll just call a combination of factors, I wound up following somebody else off the elevator one stop too early. Walked to what would have been my room had it been the correct floor, coincidentally found the door propped open, so I walked on in. That led to what I'm sure is the same question many of you have right now. Who are you, and what are you doing here? The answer to the first part is easy, as it's just my name, Dave Plummer, as I was introduced. During my professional career, I like to think not unlike Prince or Sting, I entered the single name stage of my career where I was just Dave PL. There we go. Which was my email alias at work. Because you likely won't be surprised to find out that short, single-value, unique names that never collide and that are issued by a central authority are a much more elegant and efficient way of naming people, as opposed to when I was born back in 1968 and all the boys were just named David, Michael, or Robert. So that explains the who part, but what are the why? Like many of you, I'm a University of Regina computer science graduate, so that's the real reason. But why me specifically? I have 0 papers published, but about a dozen patents, so I'm definitely more on the practical side than the academic. But what have I done that you might have heard of? And that's the beauty of it. Without even knowing it, you've probably been using some of my code all along for years. In fact, going back to the 1990s, it was pretty much inescapable that most people would be using my code at some point during the day. And that's because I was a relatively early employee at a company called Microsoft down in Redmond, Washington, which is where I've lived for 25 years now. Throw in a trivial contribution to the Linux source tree and my work on Office for Mac, and you may have been living the Dave PL life all along without even knowing it. You'll pretty much have to hide out in the Java VM if you want to escape me entirely. I started in MS-DOS in 1993 and spent a little more than a decade at Microsoft, leaving after Server 2003, so back in the days when software came on those little plastic coasters, my fingerprints were on most of them. I've already had the Windows 95 20th year reunion and the Windows NT 25th, and I was going to make some reference to coming back to meet up with the old gray-bearded programmers until I realized that I literally am one now. And since I've already jumped back to 1993, I might as well go all the way back and give you a little bio. I was born just 2 months before this department was founded back in 1968 at the Regina General Hospital here in town, where my mom was an operating room nurse. My dad owned and operated Plummer's Hardware over on College. The store was just down the alley from our house, as was my grandfather's workshop. And so every day from the age of 5 on up, especially in the summers, I would wander down and hang out with my dad at the shop, at the hardware store for a while, and then visit my grandfather at his shop. Not only did his shop feature a Coke machine, he had the key, and sometimes he'd open it up and grab us each a bottle. As a little kid, being able to open the Coke machine seemed to me to be the ultimate in power and privilege. Between the hardware store and Grandpa's shop, I spent a great deal of time hanging around with folks that were just busy fixing, inventing, and building things. I'm the blonde one. I guess we're all kind of blonde there, and I think that was formative. Of course, what was hardware for them would turn out to be software for me, but the core instincts are very similar, I think. Several years later, when I was 11 and able to venture a little further from home, I made my way into the local Radio Shack. There, out of the boxes but not yet set up, sat something I'd only ever heard of, a computer, the TRS-80 Model 1 with 4K. When I asked when it was going to be ready to use, they said they weren't sure on how to hook it up yet. In a move that would become somewhat of a theme in my life, I just offered to set it up for them, even though I clearly had no idea what I was doing. They must have felt I was precocious or entertaining enough to humor with their expensive system, because they said, "Sure, kid, have a shot," and they left me to it. In all honesty, it wasn't that much different from connecting a component stereo, except Tandy, in their infinite wisdom, used the exact same 5-pin round DIN connector for video, power, keyboard, everything. But I still managed somehow not to blow it up. It was to be my first experience with dust blinking lights, and I loved it. The more LEDs something had, as far as I was concerned, the better. Once up and running, I naively performed a Turing test on the machine by typing English commands into the BASIC interpreter. It failed miserably and responded only with SN question mark, which I decided must mean spelling error. Later, I would figure out that it was syntax, but at that age, I didn't know what syntax was anyway. I didn't get very far that first day, but I walked out and rode my bike down there every Thursday night and Saturday morning, and the manager, Brian Patmore, let me key in the basic programs I had dreamed up in elementary school in the days prior. I didn't even save any of these early programs to cassette and keyed in something new every time. I initially had no idea how limited the interpreter was, but I learned quickly. There were no books on how a kid could learn Z80 assembly language, at least not that I could find. And while the Radio Shack guys were friendly, initially they knew less about the machine than I did. And as gracious as they were about letting me exploit Regina's Thursday night shopping policy, I couldn't spend all my time sitting on a stool in the corner of a retail store. And that is the moment that I discovered the University of Regina. I found a convenient shortcut through the park near the old power plant that could take my bike from my house to the university in just about 10 minutes. And there on the first floor of the lab building, I think in 115, is Minerva, or maybe it was Vinerva, or maybe there was both. Somebody here will know. But for certain, they had a PDP-11, and I discovered that on Saturday mornings, kids were tolerated. I don't even know to this day if somebody was actually opening the lab up to kids or security was just light on Saturday mornings, but I got in somehow. And the PDP itself had the most blinking lights of all, and the hello prompt of what I think was RSTS awaited. My mom looked into it a little further for me and found that there was actually a class you could take in that lab on that very machine, and the public was welcome. We signed me up immediately, and I'm afraid to say I couldn't figure out exactly who organized that class, but it could well have been Dr. Mcguire. I think I remember that Dr. Cullimore from the science department was somehow involved as well. I'm still a little ambivalent about that class because it really entailed the typing in of a giant Snoopy ASCII art calendar. But on the one hand, I learned very little about programming, but lo and behold, by the time I was done, I was very proficient with a Deck Writer 110. I knew what to do with the PDP-11 login prompt. I even had my own account where I could save and retrieve my programs. So I used that knowledge to continue coming in on Saturdays to tinker while the summer lasted. Because they were so new and rare, access to computers would be scarce for a while. Prices would come down over time, but my family just didn't have the thousands of spare dollars it took in those days. I would continue to rent, beg, or borrow whatever computer time I could get. As much as we might disdain the BASIC language, at least it's reasonably portable, especially if you're going from one Microsoft interpreter to another. But even if you wound up in Apple BASIC, you weren't totally lost. So those little BASIC masterpieces could be adapted to wherever you managed to get access. And then after renting a VIC-20 from the public library for a couple of weeks, my parents surprised me with the news that we would be getting a Commodore 64. I don't think it was anywhere within the family budget, so it was really a stretch for them, going out on a limb. I wasn't especially familiar with that computer going in, but in retrospect, it was the best possible choice for me, and it was literally the last thing anybody's had to buy for me. It came with a machine language monitor that allowed me to get my feet wet. In those days, a quick test of how fast a computer was just to increment the screen color register in a tight loop and see what the screen looked like. In the BASIC interpreter, you'd get colorful flashing of the screen, but in machine code, it was different. The electron beam on the screen barely advanced an inch on the scan line before the color changed again. You could see the speed, and it was intoxicating. Did I just say that a 1 megahertz machine was intoxicating? It really was, though. The leap in power and speed from BASIC to assembly language was several orders of magnitude, not just one. So armed with the excellent Commodore 64 programmer's reference manual and a pad of graph paper, I set out to revolutionize the video game industry. In truth, I wrote something similar to Galaga, but with fewer attackers. By this time, I was smart enough to save programs, and this was important enough that I was even going to make my first backup, except I screwed up. Floppies did not come pre-formatted in those days, and I managed to format the original. I'm still a little bitter about that one, but ironically, in truth, that moment is so now burned into my brain visually that I have a pretty good mental image of what the game looked like, better than if I would have saved it. You'll notice I've been saying machine language and not assembly language, and at first it truly was, as a C64 monitor that I was using didn't have an assembler built in. It certainly didn't have labels or line numbers, so if you wanted to insert an instruction, you would have to jump out to free memory, do your work, and then jump back to where you were. It was the true definition of spaghetti code, something you don't hear much about these days, but it was a real thing on early projects written in unstructured languages. The year I turned 16, I finally met a kindred soul who was doing the same thing as me, whiling away the long summer months coding assembly language in his mom's basement on his Commodore 64. His name was Chris, and he knew a lot more than me, so I spent the rest of the summer standing over his shoulder, watching him code, and I learned by observation. He had actually lived across the street for many years, but it was a busy street, and I wasn't allowed to cross it. So our meeting had to wait until I was driving age. In high school, the only class I truly enjoyed was computer science, and I was fortunate to have a dedicated computer science instructor in the aptly named Mr. Bright, who was not only a great teacher in general, but also a knowledgeable computer enthusiast in particular. Not unlike a Microsoft interview question, the assignments he came up with for us often had trivial answers that then could be vastly improved. For example, one assignment was to find prime numbers. If it worked, you passed, but to get a great mark, it had to be fast too. And just as you see some kids training for football for hours after school to be the fastest, Mr. Bright would keep the lab open for us and we'd hang around and optimize our prime sieves. By late high school, however, I had sort of drifted away from computers for about a year or two as I worried about cars and girls and whatever else teenage boys care about. You'll notice I didn't say I was particularly worried about school, which I was not. In fact, at some point in 12th grade, I just stopped going. My kids will still ask me, how did you drop out of high school? Wasn't that a huge decision? Why did your mom even let you? And it turns out that dropping out of high school is one of those things that happens kind of slowly and inexorably, not overnight. You miss a class here, a test there, and pretty soon you're working the night shift at 7-Eleven, staring down a shiny blade at 4 a.m. And that's when the call that saved me came out of the blue. I'd been drifting through life for the last year or two, not in school, working in warehouses and retail, and I had no grand plan. That's when I got a call from John White, who was also a couple years my senior and a true computer savant. He had gone to my high school where he was well known as a super genius. I'm still literally doing the odd project to replicate stuff that I saw John do on 8-bit computers in the 1990s because he really was that gifted. And now he was working for a big video game company in Ottawa, and they were desperate for good programmers, and did I know anything about the Commodore 64? When they asked if I could handle video interrupts and multiplex the sprite hardware, I confirmed that I was indeed well versed in such topics, which is my way of saying, I'll figure that out before I get there. And I've done that too many times to count. But I'd watched Chris do similar tasks. I knew how the general idea worked, so I sat up late into the night and I got a rough demo up and running. I made a VHS demo tape of the video output from the Commodore 64 the next morning and overnighted it to Ottawa so that I could await their judgment, which was that I should load all of my belongings into the trunk of my old Pontiac and head east if only we could agree on a dollar amount. And I could tell they were desperate, so I really reached for it. I told them I would need at least $6,000 to write that game over the course of 4 months. And yeah, that works out to about $9 an hour, but it seemed like a lot of money at the time. I moved into John's attic in Ottawa and basically lived at work anyway, cranking out the game code in 6502 assembly. When I returned to Regina, Chris and I set up a small video game studio in the offices of Wicker Warehouse in the industrial area, and we contracted out to companies like Electronic Arts and Accolade. Eventually, I was making decent money under my new contracts, and things were looking up, except I still hadn't even finished high school. About that time, a friend took me on a tour of the U of R and the adult entry program. Unfortunately, I didn't even meet those relaxed requirements as I needed a number of classes I still didn't have. Rather than pursuing a GED, however, I drove down to the local high school to chat with the principal. After all, I wasn't a kid anymore. I was a professional young man. I should be able to handle high school. Even though I was 21 years old, Mr. Regina kindly relented and let me in. It's not just that being in high school at 21 years old is a little surreal. For example, one day I was waiting outside in my car for the girl I was dating, and somebody let her know that her dad was there to pick her up. And so, 7 years into my high school career, I finally qualified for the restricted adult entry program here at the U of R. I had to take Math 90 and 91 and some remedial classes, but once I got into the swing of things, I turned out to be a pretty good student. I have never been one of those autodidacts that looks down upon higher education as too removed from practice. I was always the opposite. I craved whatever knowledge they had acquired, and I wanted to make it my own. Even a little jealous that they had information I did not. But I was always fascinated by links to the practical. I remember sitting in the lecture hall and learning about Shannon's theorem. I pulled out a piece of paper and I did the quick math on a telephone's signal-to-noise ratio, and out popped a number that is surprisingly close to the maximum speed of the better modems of the day. And I love it when a theory predicts reality like that. The grade field on transcripts back then was only 2 digits wide, and there were 2 classes I came close to getting 100% in, but I never did it. In CS 200, I got 100% on every assignment and every test. And I can see the look on my son's face that says, oh no, Dad's going to tell the JSR story again. I went into the final exam with 100% average, and I got 100% on all the programming questions. But then I made my one mistake. There was a large true or false section, and one of the questions was, for every JSR, there must be an RTS, for which I said, well, duh, every JSR needs an RTS. Problem is, of course, that many JSRs can share the same RTS, so while I've been arguing for 30 years that it depends on how you read the wording of the question, I still got it wrong. Not bitter, not bitter. My other 99 came in one of my favorite classes, CS 300. That was our assembly language programming class. Better yet, it was all done on the PDP-11 instruction set, and we might have been using the same PDP-11 that I'd been using as a kid, but I couldn't tell for sure. Our major final project in that class was to write a game for the PDP-11 that ran on a terminal. Blackjack and tic-tac-toe were common choices, but I wanted to try a video game. I got a hold of a VT220 reference manual, and I figured out the various weird and special modes that are supported and put them all to good use for a version of the old arcade game Omega Race. It opened with a scrolling title intro screen like the Star Wars movie using the special double high character mode, and it did character-based graphics at 2400 or 9600 baud. In my mind, it was super impressive that it ran at all, but it wasn't something you'd ever play twice for fun. My other 2 favorites were CS405, graphics, and CS440, the languages tour. In my languages class, we took Prolog and Lisp and Ada and a number of languages that I would likely have never touched, if not for that class. As cool as the functional programming was, though, I was very enamored with Ada because I always felt like if it compiled, it would probably run. That's kind of how I feel about well-written C#, my current favorite language that I never get to use. In the graphics class, we started with the very basics, and we worked our way up to shading a simple house model, but all from first principles. In other words, we weren't learning how to use OpenGL, we were learning how to write OpenGL. And to me, that's been a key difference between higher education and a trade school system. Somebody has to write the languages and the tools and the operating systems that other programmers use. Meanwhile, back at home in the 80s, I had an Amiga, not a PC. In fact, I wouldn't even own a PC before I worked for Microsoft, other than an old Keystart Philips 286 that I literally pulled out of my father-in-law's dumpster to learn Excel on. I really enjoyed the 68,000 instruction set, as it reminded me of the PDP-11 in a way, and it still was made for humans to code in, unlike the RISC chips of a few years later that were really designed for the compilers, not for the coders. I was working my way through the U of R, so on the side, I started to write an app for the Amiga. It wasn't a big market by any stretch, however, so I went commercial from the start, rather than shareware. My first success was a program called Hypercache. The Amiga operating system, while advanced in the sense that it supported preemptive multitasking and similar features long before they became commonplace, completely lacked disk caching. The difference with and without my software in the machine was night and day, and it became quite popular. But by popular, I mean it paid my way through school, but I was still driving a rusty 75 Monte Carlo. So hundreds and then thousands of copies, but never millions. I drew up the cover art in Corel Paint, and we had the production run by a fellow down at the U of R's print services in the admin building. So each day after school, I'd head home with a bundle of Hypercache under my arm. And on days that I couldn't make it, my girlfriend, now wife, Nikki, could be found shrink-wrapping software in between her own classes. During my second last summer to college, I was working at SaskTel and not really enjoying it. I still didn't know what I was going to do for a living ultimately, and while I knew it would be programming, I didn't know if it would be embedded microwave oven code or video games. I had no idea. Each day at lunch, I'd eat in the Cornwall Center food court and I'd read a book. On one occasion, I wandered into Cole's bookstore and I grabbed a copy of Hard Drive, the story of Microsoft and Bill Gates. As an Amiga enthusiast, Microsoft was always kind of the enemy, but I still was interested in learning more about the company and the story behind them. Once I got into the book, interested is not the word I'd use to best describe it. Enthralled, perhaps, or entranced. I don't actually know. but certainly fascinated by the people, the projects, the environment, and how they got things done. I knew immediately and with great certainty where I wanted to be and what I wanted to do with my life. The only problem, however, was that I was sitting in the Regina Cornwall food court, and Microsoft was, at the time, receiving over 100,000 job applications a year. They did recruit a bit out of Waterloo and Ontario, but suffice to say the U of R was not really on their radar at the time. The odds of even getting an application notice seemed very remote. So what to do? My Hypercache program, like most software packages of that day, came with a little registration card that you could fill out and mail in so that I could notify you of upgrades and so on. I would come home after school and type in the stack that arrived in the mail into a little database that I'd written. Fortunately, even though it was barely 1990, I had included an email field on the form, so I went through digging for anyone that I could find with a Microsoft email address. I found 2 or 3, and one fellow responded, Alistair Banks. He's now in the UK, so I've still never met him in person, but I remain in contact with him to this day, and I sent him thank you notes on my major work anniversaries. I asked him where or to whom I should send a resume to maximize the chances of it being seen, and he gave me the greatest gift you can give to an aspiring graduate, the contact email of a few managers that were actively hiring new developers. I put together my resume and fired it off directly to them. Within a few weeks, I had a phone interview with Ben Slivka, who ran the MS-DOS development team and who would later start the Internet Explorer project. Although even the phone screens with Microsoft were rather technically demanding, you didn't have to code live on the phone, so I could hide my lack of x86 specific experience to some extent. I managed to knit an interview loop in Redmond in February, and Microsoft, to its great credit, takes care of everything. You just show up. Their legal department does the visa work, for example, and they make all the travel arrangements. Although they assumed that being Canadian, I would fly through Toronto, because all Canadians fly through Toronto. Microsoft interview loops used to be famously grueling. You spend the entire day there. You start with an HR interview to make sure you're sane and bathed, and if so, then you're off to a series of 5 one-hour coding interviews where you stand at a whiteboard and you answer brain teasers and write C in assembly code until you can't go any further. They push you until they stump or break you, and then depending on how those first 5 go, you might make it to the as-appropriate interview, which is the hiring manager. The answer is Boolean at each of these steps, hire or no hire. There are no maybes. You only get to the final interview if everyone else has said hire, generally. Since the team must be fully bought in on who gets hired, it's not just up to the boss. The coding problems are simple tasks that you can fit onto one whiteboard, like how to reverse a doubly linked list, or how to count the number of bits that are set in a word. Attempt to factor a prime, that sort of thing, where there's an obvious and trivial approach that can be refined and optimized. You want to see their thought process, and you want to see what they consider good enough. Take the approach or the case of counting the number of bits that are set in a 32-bit word. The naive approach is to OR it with 1, increment the counter, shift the word, and repeat. Do that 32 times and you've got your answer. But that can be improved. You can stop as soon as the remaining word is 0, right? And as the interviewer, you watch to see if the person picks up on those little optimizations as they chew on the problem. But what about long runs of 0 separated by 1s? That seems like a waste of time. Well, it turns out that instead of ending with 1, you end with the number itself less 1, and that way you only do 1 operation per actual bit that was set. If 3 bits are set, you only do 3 tests. In other words, there's the simple answer, the fast answer, and the smart enough to get yourself hired answer. I learned quickly that I'd made it, and right after final exams finished here at the U of R, I flew down. After a couple of hours of new intern orientation, they gave me an office, an account, and a copy of the MASM assembler. From there, it is sink or swim. Remember, it's still 1993. There's no World Wide Web, there's no Google or Wikipedia or Stack Overflow. I've never written a line of x86 code in my life before, and they're expecting me to be productive immediately. I'm sitting in an office with a chair, a desk, a USB-C, and a network cable. I can't overstress the straight into the fire part. It's not like it's Astel where they give the intern a token task that he can't screw up and won't cause a problem when he inevitably does anyway. In contrast, Microsoft has me working on the core code base for new features for MS-DOS, which is a multi-billion-dollar business. Bill Gates has us over to his house for a barbecue to talk about it over a few beers, and I'm supposed to act like this is all normal for me. Do they take their interns seriously? There are perhaps only 5 or 6 developers in total on MS-DOS, and most of that team is feverishly rewriting the hard disk compression engine to not use a hash table, which it turns out that the Stack Corporation managed to somehow get a patent on, and Microsoft lost a lawsuit over. Thus, it's me and one other intern developer responsible for pretty much every new feature in the operating system, including the new setup program. To ease into things at least a little, my first task was to make disk copy single pass. At least it's a standalone app that I can assemble and build, something I get my head around and tinker with. The prior implementation was limited to RAM only, and so would require many swaps to complete a disk copy. The hardest part is finding a safe place to store a temporary copy of the floppy disk when there are a million different possible system configurations. Remember, you accidentally store a temp file on a metered network share, and that's a class action lawsuit. If you assume the C drive is a hard drive, perhaps you crash a helicopter, an ATM, or a defibrillator. Who knows? That's the biggest trick in coding for a billion machines. It's like you're building one bowl to be released into an infinite number of China shops, and you've never seen any of them before. If it can break or go wrong, it will somewhere. It's truly a different philosophy of coding. My next task was to limit the RAM use of the double-space compression program. As you might recall, memory back then was limited to 640K on MS-DOS, so everything you could move above that barrier meant more free memory for useful things like applications. And the x86 has an interesting feature where your segment and your offset registers can add up to slightly more than 1 megabyte. Basically, your pointer wraps around to the start of memory again. Sometimes. It actually depends. If the A20 keyboard line is high, then the pointers wrap around back to low memory. If the A20 line is low, then they point past the 1 meg boundary. I used that ugly hackery to move the engine up above the 1 meg boundary and stub every function call into it with this funky pointer math and exploit the CPU bug, freeing up a ton of low memory. And that's the kind that actually got magazine cover stories back in that day. Next was to attempt to save the company money by putting the upgrade on a single floppy disk. While MS-DOS 6.2 might ship on 4 or 5 disks, what if you already have MS-DOS 6.0? What I did was to write an upgrade system that patched the 6.0 binaries in place with the deltas to make them into 6.2 binaries, and discovered that all of those deltas combined were still small enough to fit on a single floppy. Thus, we were able to offer the MS-DOS 6.2 step-up upgrade on a single disk, saving several dollars per copy, multiplied by tens of millions of copies. A single little project by an intern generated millions in savings. And then the real work began. Because of my experience with Hypercache, they appointed me to write the Smart Drive cache engine to be more generic and support all kinds of block-level devices, most notably the CD-ROMs that were just coming into the market at the time. Caching made an epic performance difference on CDs. All of this work only took 3 months, which I still have trouble believing when I look back at it. If I had to schedule that amount of work now, I'd be looking at a year. But it's amazing what you can accomplish when you're young, broke, and hungry. Even though I felt I'd done a good job, there was no guarantee that an internship would ever translate into a full-time position. When my summer was over, I came back to Regina to go back to class and hoped the phone might ring one day. And I remember exactly where I was and what I was doing when that offer call came in that fall. I was being offered a full-time software design engineer position in Redmond with complete relocation benefits, visa and immigration assistance, the works. And the salary? Are you ready? You've all heard of the Microsoft millionaires of the era. Well, it was $35,000 a year. That's all they were paying, but I didn't care. I didn't negotiate. Whatever it was enough. I wasn't in it for the money, even if I thought I was at the time. It wasn't until the UPS drivers went on strike that summer that I found out they were making 50% more than I was. But I didn't really care, and there were these other things called stock options that worked out okay in the end, so don't feel bad for me. What I found especially interesting was to compare notes with the other new hires from places like MIT and Harvard. They got the exact same offer I did, right down to the penny. I don't know what it cost to go to Harvard, but I bet you could save 15% or more by switching to the U of R. Microsoft again suggested that when I fly down, I come through Toronto because they'd been having trouble in Vancouver. Too many Canadians coming down through there to work for Microsoft all of a sudden, and they were starting to push back hard on the visas. Toronto being a little silly, we agreed to compromise on Calgary. My fiance and I flew in, and I got taken into the big glass room for the immigration interview. As she watched from the outside, she could see him flailing his arms and turning red in the face and yelling. Clearly, I was headed back to Canada, and my Microsoft dreams were not to be. But what she didn't know, because she couldn't hear anything, was that he'd already long since stamped and approved my work visa. He was upset because every time he printed his form in Word, it would print a blank piece of paper at the end, and it was wasting paper. And since I was going to Microsoft, he wanted me to fix it right there. That May, I flew back one weekend, convocated from the U of R on Friday, got married on Saturday, and then permanently relocated to the US on Monday. And by the way, if you're planning a wedding, I strongly endorse the approach of hiding in another country while all the hard decisions are made for you. Then you just fly in the day before, fly back out, hassle-free. There I am, my Bob shirt. As for my career, other than that internship in MS-DOS, I managed to dodge the x86's ugly 16-bit mode entirely. While the 16-bit guys were feverishly working on Windows 95 on the other side of campus, we saw ourselves as the real programmers, working under Dave Cutler, who had just finished the VMS operating system in perfect hand-coded assembly language, and we produced real code in pure C for multiple platforms. In a somewhat ironic turn, I still didn't have a PC as my main machine because I was assigned the job of porting the Win95 user interface over to RISC chips, and so I had a MIPS R4000 workstation instead. Working at Microsoft before and after my final semester at school led to something I think is entertaining, although it might have been a source of annoyance to Dr. Hamilton at the time. I had run off before my 4th year to write major portions of the world's most popular operating system. I guess it's perhaps somewhat fitting that my work on MS-DOS came in between the Introduction to Operating Systems and the Advanced Operating Systems class. If nothing else, if I wasn't the only guy in the operating systems class with a published OS under his belt, I bet mine was the best-selling. I spent the majority of my career in Windows NT, actually, which became Windows NT XP and is now, today, Windows 10. I continued to write projects at home as well, which I'd sell as shareware. One such example was a product called VisualZip that lets you treat compressed zip archives as if they were regular directories, browsing down inside of them and so on. I was selling maybe a dozen copies a day when I received a call early one morning from Microsoft who was interested in purchasing VisualZip for inclusion in the Windows operating system, and would I be interested in coming in to talk about it. I hadn't left for work yet, so I asked what their office number was so I could stop by. Well, this led to some awkward confusion until we finally realized the person I was talking to didn't know that I already worked there. They had just cold called the author of this program, who happened to be me at home. We came to an agreement where Microsoft purchased VisualZip from me, and we included it in the operating system. I'll abbreviate a long and complicated story to just say that when your options are take the deal or quit your J job and compete with Microsoft, take the deal. The Windows Task Manager that you've no doubt seen also began that way, as it was another shareware app I wrote in my den that I was planning to sell on the side, but when Dave Cutler saw it, he agreed to let me check it into the product, so I donated that one to the cause. Surprisingly, both VisualZip and Task Manager are still alive and well in the product some 25 years later. A large part of my early work was to take all the code that's coming out of the Windows 95 and Windows 98 projects and rewrite it for NT. That meant taking code intended for the x86 processor running 8-bit ANSI text in a home and making it ready for server-level quality on a RISC machine with 16-bit Unicode text. Because char and byte are used interchangeably by most C programmers, it really means you're changing the assumption about how big a byte is, and it becomes 16 bits, and almost all code breaks immediately. There were just dozens of other issues as well, like they assumed a broadcast-style small network while we were on TCP/IP with long timeouts, so many things became entire architectural rewrites. Of course, on our behalf, we were totally immune from the realities of being forced to be compatible with a million random software titles going back to the 70s, not to mention operating with a lot fewer resources than we did. And so you can imagine when your job is to take somebody else's code, tell them why you think it sucks, fix it properly, and give it back to them, which is what we did, day after day, week after month, some tensions developed between the teams. And then they merged those teams, which did not go so well. So I wound up heading off to move to the copy protection, head up the copy protection team. I actually had a wake chorus of boos here after I announced copy protection, but it's true. I am the evil monster responsible for making you enter a product key in order to activate Windows. At least I'm the guy that's responsible for making sure two different people in the universe don't use the same key. There's two major tensions in such copy protection. You can't annoy the users, at least not any more than the bare minimum required, and you can't let normal, everyday people steal the product. And the worst case to me is annoying regular users without slowing the real pirates down. I can't go into all the cool technical details of self-modifying code that decrypts itself on the fly and all of that, because I suppose it's all still trade secret. But suffice to say, I think it was almost 18 months before an easily pirated version of Windows XP actually hit the web. So in my mind, the protection was a great success. On the side, I've been selling 3 small performance utilities for Windows, BAMTurbo, NetTurbo, and a program called ClipTracker. On a good day, I might be sending out 24 mailers, making a few extra $100 that day. And then one day I discovered internet advertising. This was in the Wild West days of pop-ups, no less. I was by no means the first, but my ads were very effective. When you're selling software on the internet, your 2 basic fundamental metrics are how much did it cost me in advertising and everything else to sell it, and how much did I earn? Computers are great about tracking these details, and in those very early days, I found that it cost about $10 to sell a program for $50. You just rinse and repeat as fast as often as you can. And so I bought millions of advertising impressions that ultimately became billions of impressions over time. The problem was that now, literally overnight, I was selling 1,000 copies a day. It sounds great, and it is great, but I had to come home after work, duplicate 1,000 floppies, then I had to print 1,000 mailers and 1,000 diskette labels. I had to get them assembled. There'd be about 2,500 emails to answer and 50 returns to process, and it was just me and my wife. And I had 2 kids and a dog and a rather demanding day job. So we hired friends and family to come in and put stickers on discs and answer emails as fast as we could until we eventually got caught up. All of this was making it rather hard to pay attention to my day job, but Microsoft was great and they allowed me to take a 3-month leave of absence to figure out what it was that I wanted to do with my life. And it turned out that what I really wanted to do at that young age, like a lot of people, was to make a lot of money and be my own boss. As a result, I turned my back on everything I'd come to love about my day job to focus on my side business, which was now the main business. As of this point, at least, I've never gone back to work another day for anyone else. Running your own busy software business is fun and exciting, and I had a great time doing it. I hand-wired every office for Cat5 and hand-terminated every cable myself because I wanted things just so. But in reality, I'd already worked for the world's biggest software company, and I didn't want to try and build a little clone of them. And to be honest, when I was pedaling my bike down here to the computer labs on Saturday morning as a kid, it wasn't because I wanted to manage a group of other productive kids. I wanted to program, to code, to figure stuff out, and write hard logic that would impress myself and my friends. And that's how I wanted to spend my days too, not with customers and program managers and lawyers. So, in addition to the boring business side of the company, the live data reporting, analysis, and the AI systems that we built to optimize sales were fascinating. But in the end, like the company itself, it was all in the service of simply making money. My first attempt to retire away from it was to hire professional management, but that didn't go especially well. I ultimately decided to sell the business in its entirety to Support.com down in California and officially retired to sit around and write more fun code all day. There's a great book I recommend called Showstopper about the early development of Windows NT. In it, they discuss a conversation between a friend of mine, Bob Day, and his wife when they were talking about what Bob Day really likes to do with his free time. Bob likes to code. Well, there must be something else he likes. Cars, maybe? Sports? Science fiction? No, Bob likes to code. And that's what Bob still does, too. And that's what I do as well, because I just love to code. So it's true, I get to spend more time with the family, and I travel a little bit, but mostly retiring has meant that I get to write as much fun code as I want. To be fair, however, I also spend a lot of time restoring antique cars, and I undertake a lot of mechanical projects like solar panels for my shop or this microcontroller-controlled 1,500 horsepower twin-turbo fuel-injected intercooled big block engine that I built from cheap eBay parts. So I actually alternate. I code obsessively until I need a break, and then I undertake some other project in another discipline until I miss coding. Why the focus on writing new code? I think it's perhaps because that is the biggest difference between expectation and reality as a new programmer entering the workforce. As a student, you come to think that you'll be crafting great template libraries that drive some super complex production process with great elegance. But in your first years, you're really just tracking down an off-by-one string buffer error in some ancient client building code at the Saskatchewan wheat pool. Unless you wind up at a startup, and maybe even then, you'll start fixing other people's code. So your experience as a student of writing 95% new code becomes 95% debugging and maintaining other people's code. That will change over time as you gain experience, and debugging other people's mistakes is actually a great and effective way to develop that experience. And because I love to write new code as much as the next person, in the last couple of years, I will pick a project, whether it's writing shaders that look like natural water phenomena or running my home automation. I'll start a new notebook and I'll just start building. Anything I start like that has maybe a 20% chance of getting finished with the website and help files and all of that, but I think that's still a pretty good ratio for someone in my position. The hardest and easiest part is finding information about what you're working on. By that I mean we have the blessing and curse of things like Stack Overflow, which can be a bit of a rough and tumble environment if you're new to a subject. If you can find the ear of an expert, you can learn a great deal quickly. But if your topic is too general, like, how do I get coded starting C on the Mac? It can be a rough crowd on some days. My project this summer was to build a cool LED audio spectrum analyzer. Back in high school, John White had built one out of discrete components like filters and op amps, and there was an entire daughter board assembled on top of the motherboard of his PET 2001. But I was going to use strictly software and a modern microcontroller, and I wanted to do it all on one chip. The ESP has 2 cores, and they each run at 240 megahertz, so I have one core continually processing the math FFT, while the other core is continually drawing the display. As those cores are churning away, the chip wakes up some 44,000 times a second to sample the digital audio. The chip is really quite about at its limits, and I love projects that do that. It's like when you get your washing machine working really hard on a cycle. If nobody else is home, I'll still jam the lid switch open and sit back and watch the machine at work, even at the age of 50, and I really have no idea why. Now, of course, a spectrum analyzer has been done before, and it will be done again and again because it's a cool and beautiful programming project, and when you're done, you wind up with a lot of dust blinking lights. And the more dust blinking lights in your life, the better. That almost brings us full circle, from a childhood of tinkering to a retirement of tinkering. Although advice wasn't really my goal, in summary, I will offer 2 little suggestions for those just entering the field. My first piece of advice, and it might even be bad advice financially, is simply that if you love coding, find a career path at a company that will let you code and advance until you've got it out of your system. Resist the temptation wherein you code only briefly before you start accumulating reports and management duties and living in meetings, unless that's what you really want. Dave Cutler is 76 years old. He's put in Microsoft in 30 years, which is his second job, and he still codes all day, every day. My other is to find mentors. I learned a great deal from a small handful of great teachers and professors, and I imprinted on a few key people that were about my own age, give or take, but I never had an official industry mentor to lean on and to learn the ropes from during my career. It sounds obvious in any field, but I contend it's actually much more challenging in computer science because the people you really want to talk to may not be the chatty, outgoing, ebullient folks you'd find in sales and marketing and HR. They say there's a wide spectrum for people with Asperger's, and I think I'm likely somewhere on it myself, although often what I like to call the non-visible part of the spectrum. But I don't think I'm alone out there. One of the guys on my team at Microsoft had actually won an Oscar for previous work at Pixar, but even he said they give out the technical Oscars on a different night with no fanfare or red carpet or acceptance speeches. So that makes any opportunity to speak about a technical career all the more rare, and for that I am deeply indebted to you for your time tonight. I want to thank you all for coming out. I believe Dr. Hamilton.
So thank you very much, Dave, for that. That was enlightening. And for those who don't know, Dave Plummer was one of the stars of my very first class at University of Regina. And every assignment, I had a marker, but I had to check over all the marks. So I knew every assignment submitted by students. There were 21 students in the class. And there were two students, Dave and Jeff Hamiluk, who submitted the just stellar assignments, just perfect each one. And Dave went on to do very well in the class, but on the final exam he got a question wrong, which he may still remember because for about the next 10 years, every year he'd say, I've been coding on, such and such version of the world's most popular operating system, and I still don't know what Peterson's algorithm is, because that was the question he got wrong on the exam. So we're hoping to rectify that one day soon, and then Dave will know it all. But thank you very much, Dave, for coming and giving us that speech.
Good evening. My name is Malik Muhub. I am the current department head for computer science, and it is my great pleasure to introduce Brian Mcguire. So Brian graduated with an undergrad degree in mathematics from the University of Saskatchewan in '68. Then he moved to Waterloo and received a master in mathematics and a PhD in computer science. After that, he joined the Department of Computer Science in '72. He was the third hire after Larry Simus and someone else that I don't recall the name, who just stayed at the department for less than a year. Brian became full professor in 1983. He has been department head for more than 16 years. Or as he used to say, 6,022 days, excluding February 29 on leap years. Then he became Associate Dean Academic from 2007 to 2009, and then Acting Dean of the Faculty of Science until 2011. And finally, he retired in December 2015. So Brian was an excellent teacher and an administrator. He has taught one class in particular several times or many times, and this class was offered first time in '71, '72, and we are still offering it right now. Can someone tell me what's this course? There's one course that has been offered in '71, '72, and is still being offered even this year. Huh? No. 100, exactly. Yes. So, and I remember Brian always telling us a story about students in a particular class that I don't remember, maybe 300, where at the end of the semester they just showered him with a set of punch cards. So for those of you who don't know what is a punch card is a little piece of paper that contains one instruction. So you remember, so just you can imagine if you have a set of assignments over the semester, how many punch cards they have thrown on his face. Okay. Thank you. So it's my great pleasure to introduce Brian Mcguire.
So, first of all, let me correct one thing there that Malik said, it wasn't punch cards. It was all of the chads from the punch cards. So now you can think of how many pieces. I don't know. I mean, I was still cleaning those things out of my hair months later. And I thought they all came up with these cardboard boxes. That's how you could tell the serious programmers. They had 2 boxes of cards. I think a box held about 2,000 cards. I thought that they were all about to turn in their, it was a compiler class. I thought they were going to turn in their assignments because they still had some time. And then the boxes were opened and I was showered. Anyway, I'm going to see if I can show a few images here. Oh yes, Daryl said, okay, start off, tell a few jokes. Well, I don't do jokes very well, but let's go with this one. You may be able to read it, but I'll tell it to you anyway. So there's a man and his wife walking along near the Kremlin, and it's a kind of a miserable, sleety day, and they're arguing over whether or not it's snowing or raining. The husband says it's raining, the wife is saying it's snowing, and so the husband notices somebody he knows, minor party official. He says, hey, Rudolph, come on over here and help settle an argument. So Rudolph comes over, here's the background, all of this stuff, and then pronounces that, of course, it's raining. Well, the husband's very pleased with himself, of course. The wife, not so convinced, she's still arguing. Husband says, no, no, no. Rudolph the Red knows reindeer. Yeah. That apparently was the reason that I would frequently get comments on the student evaluations about the level of corniness of the jokes that I would use in class. So we won't subject to any more than that. I'm supposed to see if I can actually move forward with this thing. And so I was just handed this. I don't know how to work this technology, or it's not working for me. There we go. Okay. 3 things on here. First of all, and having just heard from David, on the right, that's Microsoft in 1978. There's a Bill Gates, a very young-looking Bill Gates in the bottom left corner. I don't know the names of the other people. I think on the bottom right corner is Paul Allen. But when you have a look at some of the pictures that the department has posted from years gone by, this is just my way of saying everybody looked like that in the 70s. On the bottom left picture there, this is the crowd that attended tonight. That's what we're going to tell the president. Top left corner, I'm looking for somebody here to tell me what that is. Come on, folks. Any CS300 people here? See, this is my problem. I taught that fool assembler language class so many times that these things still roll around in my head. It's why I can't, I'm going to refer to my notes when I'm introducing the panelists here in a second, because I don't have any brain cells left for new information, because these things are rolling around. 01, that's a move instruction. 06 is an add. 02 is a compare. You shouldn't know these things at my age. That's immediate mode, 27, okay? The instruction is fetched, that's the first line, and register 7 is being used. By now, it's been incremented after the fetch, or as part of the fetch, and is now pointing to that 3660, and the 2 is telling the processor, use that value. So it just knows that this is a value. That happens to be octal for 1968, and 37, we've now incremented register 7 again. It's now pointing to the 3742 that gets fetched, and the 3 says immediate deferred, but we always called it absolute. It's absolute mode. It says that's a memory location that we're referring to. So we're moving 1968 into 2018, which is what that second number is. Anyway, we're attempting to do that. And I was sure that I was going to find somebody in this audience who was just going to call out, well, that's a move instruction. What the heck? But anyway, you're too young. That's the problem. Okay, so we're going to get, I'm watching, we want to get to the cake that's out there. And so I think I'm going to just post some of the pictures. I have some pictures. Maybe we can move to the Bob Fraser picture. Forget that. That's an argument, that set of pages that just went by. That's an argument in 1969 between the assistant director of the computer center and the director. With the assistant director has said, we got to buy some more key punches and make the students do their own key punching, because that's so much cheaper than hiring staff to punch programs for the students. And the director is saying, are you kidding? There's no way the students will ever get their work finished if they have to key punch their own programs. Of course, by the time the department was moving, we kind of ignored that and just laid on the code that had to be written. But anyway, over there on the right, that's the MLAC in its better days. That's Bob Fraser. I know from many discussions with Bob over the years that Bob is convinced that he's the first graduate, although every once in a while he would say, but there was somebody else. And then he'd come back and say, but I know I'm the first BSc graduate from the department. He's not here to argue with anybody. The record keeping, not so great. Anyway, let's get the panel up here. We've got Donna Lindskog, Trevor McDonald, and Thomas Boxall. And you're supposed to come up and grab a chair. And are we supposed to allow David to come on up and get, okay, David, where'd you get to? There. So I've got a set of questions. In all fairness, we've let the panelists have a copy of these questions. Let me do a brief introduction. You already know David. Donna? Donna did a master's with me. Boy, was it that long ago, Donna?
Yeah.
Anyway, Donna, is it the Cooperators? Yes, Cooperators in SaskTel, now retired. Donna has been involved with KIPS, with computer ethics, with all sorts of activities that have earned her a number of awards for her activities. But the real thing here is, you see this, what's often called the Snoopy jacket hanging over there? With that on the breast there, it looks like what's painted on the MLAC there. Donna knows who the artist is that rendered that dog, and she also knows the artist claims that it's not Snoopy. Feel free to ask her about that and any of the other stuff she's done in her career. Trevor? And Trevor graduated in '94, BSc in computer science, and has gone through the roles. I'm reading now: programmer analyst, systems analyst, IT manager, and IT director. You just kept going till you were way over on the dark side, didn't you? So anyway, Trevor is currently the president of KIPS Saskatchewan, as well as the director on the KIPS National Board. So I didn't have any KIPS questions on here, but if you aren't familiar with the Canadian Information Processing Society, Trevor's a good fellow to ask. Thomas, yet an alumni, IT professional, has designation. These designations are from KIPS again. Started with the Canadian Forces as a signal operator. I don't even know what a signal operator is, but and has done a tour of duty in Afghanistan. Glad you're with us. Anyway, software developer for ISM, worked for Lexicon Systems Group, and currently with SaskTel. So we've got folks with a lot of experience in the local IT sector. That may frame some of the questions that you might want to ask, which is my indication that questions, feel free to ask questions or put up your hand and tell me you want to ask a question. But we'll start with one of mine. Okay, David maybe. So, do you believe in Santa Claus? Provide proof of existence, non-existence, show your work.
I had this actual argument with a son today who's 18, and the conclusion I could only come to is that I have seen Santa Claus at the mall, and that's all I'm claiming.
So, now, as I had a comment from someone near and dear to me suggesting, oh my God, you're going to ask boring questions? The answer is yes. So let me fire one. David referred to coding forever, basically, if you like to do it. So, Trevor, how would you like to tell us how long it was before you stopped coding and went on to other things?
Am I ever glad I got this question? So as you'll notice in my introduction, I raced through the roles of programmer, analyst, systems analyst, and towards management. I spent probably 4 years at the beginning of my career coding. And all I can say is that I'm very grateful and mediocre skilled people like myself can make a living in IT. I found myself gravitating towards leadership. I like mentoring and teaching others, and being the team lead. Eventually, that led me down the path. So 4 years.
4 years, okay. Why don't we do this for? We know about David. So, Thomas, how about for you?
I've been quite blessed over my career that I've been able to touch almost every business programming language that is used in North America, at least some point in my entire career. So I've actually gone into a point of a bit of a game where I usually, when I do mentoring and talk to young people that are coming up in the IT career, where I say like, okay, name a programming language, and I will tell you whether or not I've actually used it or not, and I've only been stumped once.
By what?
It was a programming language called Joule.
Anybody know what Joule is? Okay, we're with you.
I said, well, it stumped me. So. No, Jewel. Yeah, like I think when I actually researched it a little later on, it's actually probably something I'm gonna have to research myself and say like, well, I'm gonna have to figure out how to code in this thing because it was so obscure. It was a programming language specifically designed for artificial intelligence and machine learning, and it's a relatively newer language that was based around that. So I saw that and I was like that's the thing is like I always said, well, if I ever get stumped, I'm gonna have to figure out what that language is so I can learn it, and then I can't get stumped by that again.
Donna, how about you?
At the cooperators, I did COBOL for 2 years, and then 2 years of COBOL at SaskTel before I decided I wanted to work part-time, have my kids at home, and so I got into more standards and stuff like that. So, and then when I went back to do my master's, of course, you expected me to remember to how to program in C++ after more than a decade. And so that was an experience. And HyperCard and some of those that I got into with you. But yeah, no, there's only really the 4 years that I was paid to code. And after that, it became more like project management stuff and then into management. And, yeah. Actually, one of your other questions was how do you get involved in this business? And I had originally planned to be a social worker. My dad was a social worker. And I went into a career counseling room at the high school, and they had a little pamphlet that said, "Careers for Women." And well, that just, if you know me, that kind of got my ire up. So I said, I'm going to show them, and I opened it up, and it said, "Doctor, lawyer, computer programmer." I went, "What's that?" So I, I went off, and at that time, there were no computer science classes at the high school, but there was a computer club, and we typed up we used the key punch, and we made a card deck, and we mailed it into U of R, and they took our listing and wrapped it around and put it in the shoebox and mailed it back to us. So I always win all the discussions about the slowest response time. It was at least a week for every one of those decks, because Canada Post takes that long. Anyway, but as my career changed, I ended up as a relationship manager trying to get the marketing people and the IT folk to play nice together, and I thought, I'm a social worker, I swear.
Okay, folks. How about somebody from the audience? Question for our panel. Yes, sir.
Do you think robots will take over the world and overthrow humanity?
I'd like to answer that question and say, I don't think they're smart enough.
Yet.
Donna, you got a position? David, you got a position on this?
I don't on the robot question. I know AI is a big concern for a lot of people, and I think, honestly, at least in the next 20 years, it's pretty overstated. I think longer term, you have too many unknowns to really guess, and that's really up to science fiction. Near term, I'm not too worried.
Well, there was a prep question about AI as well, and the one thing I always think about when I think of AI, I always think of Isaac Asimov and his and all of his different series about basically robot intelligence and essentially AI. And the one thing that always comes back, I always come back to is that a lot of people get to the point where they think that AI is going to act like humans or cats or mice or even like viruses. They're not biology, they're machines, and they're always going to be slaves to logic and slaves to their processing. So I don't ever think that they're ever going to get to a point where they're going to replace us through malice or the need to expand out. It's more going to be they'll replace us because we're just irrelevant and can't keep up with the ever-growing technology.
Well, it's a pleasant image.
Yeah. I think the next fun to come is about the governments getting involved. I don't know if you knew, Germany passed some laws about what they thought the rules should be for the AI and these self-driving cars. I'm going, if we're getting politicians involved in defining our specs, we're in for a rocky road for a while. I don't know. I mean, it's good. I think everybody, society in general, needs to have that discussion about what kind of role we want for those robots and self-driving cars.
How about somebody from the audience? Anybody from the audience have a position or a concern about, well, whether it's robots or AI? It's the AI we hear about all the time. Is that a hand at the back? Yep. So has anybody in the audience had a problem with anything from a company that was using software to deal with their records, their order, whatever? Well, I think that's a response to where the current state of AI might be, but yet, that's a concerning word. Daryl, did you want to do something about cutting a cake, or do you want to keep going with questions? Okay, so when the cake appears, I'll stop asking questions. Sounds good. All right, I've always loved asking this question of anybody that's had any experience in going to post-secondary education, in particular computer science, and the question that I'd like to ask, and maybe it's not a fair question to ask of people that actually decided to go to university, into a computer science program, and so on. But the question is, what would you change in computer science education, or computer technology, or information technology, or, you know, it's obviously related to the idea, we argue all the time with people who hire our graduates that they're not ready, and, you know, I know eventually my answer got to be, you know, they don't have to pay enough to be made ready. You know, give us money and we'll do a better job. That never resonated with anybody in either government or business. But anyone, audience, panel?
I think I'll answer just from a broad perspective. I think computer science curriculum needs to be included much earlier in a person's education, and it needs to be more of an offering within the pre-K to 12 school system. But what we see today is curriculum is, you know, different across even different schools, let alone school divisions. And what I see is that by the time post-secondary comes along, some of the problems we have filling seats within our programs are based on that lack of awareness. If the seed was planted a lot earlier and technology is everywhere, so I think the seed would grow quite quickly. I think that not only would people be educated, you know, in a better way that lines up to the technology around us.
Yeah.
Oh, okay.
Maybe
Sorry,
pull the mic a little closer.
It seemed like it was giving me a lot of feedback, yeah. Is that worse or better? That's better. Okay, I'm sorry. Yeah, no, just the whole
How early would you start it?
I would start it as early as you could. Like, I mean, the fact is, even kindergarten, you're interfacing with machines. There's tablets in some classrooms and not in others. What I would like to see is more standardization and using and learning technology along the entire education cycle, rather than getting into grade 12 and now you're starting to think about what you're going to do post-secondary and then having an opportunity to get involved in computer science, and it's too late by then. Math.
I've got a comment on that. Having spent some time.
I was just going to say there's a microphone in the aisle there.
Oh, okay. I've got a comment on that. Having spent some time at the Department of Education or Ministry of Education on a committee trying to deal with design of computer science curriculum. And, you know, we had a fine time talking about computer science curricula. But then we proposed that what we as a committee would like to do would be to meet with some of the other committees that we're doing work on subject content for different disciplines, because we'd like to talk to them about how could you integrate computing into what you're doing in your discipline. No way would the ministry touch that. Anyway, been waiting years to say that.
Just to further add to the conversation about IT and education, I agree with Trevor on we need to get IT education and the IT skill sets of troubleshooting and problem solving as early into the curriculum as possible. But to address more of the post-secondary, when I worked for Lexcom, I was a manager there and I had my own division, and I was hiring people that were both SAS Polytech graduates and university graduates. And the one thing that I noticed as a common thread between the two institutions was that if I needed somebody to do the job today, I'd hire a SAS Polytech student because they had the skills coming out of SAS Polytech to do the job that I needed for them to do at that point. But if I wanted to develop somebody into especially the people that I was looking for more senior positions that are going to be the people that I'm going to grow certain areas of my company, I looked at university students, because one thing that university education did quite well was teach you how to learn. What I'd like to see going forward, though, in the university degree is more of the background of a breadth of knowledge in different areas, so that there's that more of an understanding of the building blocks and the foundation necessary to further their education once they leave university and go into the, even if it's just with a bachelor's program, go into the industry and then be able to say, well, I don't know this, but I've used this, which is similar to it, so give me a week and I'll be there. That was one of the things that I found with myself, with my career, and the different languages I learned became very, very effective for me. It was that it's like, yeah, I don't know JRPG, give me a week. And they come back in a week, yeah, I can do that job for you. Kind of like what David was saying with, it's like, oh yeah, no, yeah, I can do that.
All right, I can use my teacher voice. Oh, there we go. So I am actually a high school computer science teacher, one of 5 in the public board. I completely agree that we need it earlier and sooner. There's only computer science in grade 11 and 12. And I run a computer science or a coding and robotics club after school. But I have exactly 0 computer science background, except being raised around computers. And learning HTML as a kid. I think if you want to improve it at the university level, you need to actually train high school teachers. It's not possible at either the U of L or U of R or U of S to get a education degree in computer science. That's not an option currently, and that's really problematic. And even, the government's like, oh, we're gonna do this new robotics program starting in grade 7, but like, as far as I know, there is no curriculum, and there's been 1 PD session that I've heard of to train people for that. So, yeah, it needs to be earlier, but you have to first train the teachers.
I definitely agree with that, and also, sorry, yeah, go ahead. Related to that is also the counselors in the schools also need to be trained in IT, the different careers that are in IT. When I graduated from high school, my career counselor said, "You're really good at math. You should become an accountant." So, so I did accounting for 2 years in university before I realized that this was the worst choice for me personally, and that I would not enjoy this career, and I had no idea what I was going to do for the rest of my life. Now, I was lucky enough that I had family members that I've been programming since I was yay high. So they said, well, why don't you go into computing? And I was like, well, there's not a career in computers. Yeah. So I've been doing that for now, oh, God, over 20 years.
Just getting started. David, you look like you wanted to talk.
Yeah, one thing, I volunteer a bunch for the 5, 6, and 7-year-olds at my kids' school because they take it, it's a private school, it's not part of the public curriculum, but they take computers from, I think, first grade or second grade on up. And there's a huge disparity between the kids you can tell that have used a computer before and the ones that have just never touched a thing before. And it's a big jump start, I think, for the kids. And having an equalizer in there would be huge. So the two things that I would change in the industry, and that really goes to my second point, well, I'll make that my first point, and that is really feed more women, especially, into my industry, because the industry is absolutely willing to hire as many qualified technical women as you can send at this point. The system just isn't feeding that many to the industry, I think, at this point. And I don't claim to know where the fault of that is, but I know it's a big glaring disparity right now.
Guess what? I have an opinion on that. There's no silver bullet is the answer, right? It takes people working with people and getting out there and doing one-on-one things at science fairs and everything else to get that idea in their head, like you say, that, you know, somebody's got to tell them that it's an option and what it looks like and whatever. It would also apply to First Nations. I did a bunch of science fairs out at First Nations, and some of those people didn't know what a mouse was, never mind consider a computer degree or any kind of job in that industry at all. So, Larry, just saw you there. Yeah, it's there doesn't seem to be any way. I was on IT sector partnership for a number of years. We had those discussions, like, why aren't you sending more women, more First Nations up to the university? We'll train them, we got jobs for them, you know, there's directions. And always it came, well, you know, they aren't, you know, they don't even know it's there, right? So you need to somehow get into that mind. I'm optimistic. My granddaughter is in grade 5, and my son just told me they went on a field trip to the Apple store and she learned to code. So that's more of that needs to happen.
I'm going to jump in on that one again. A lot of the research that has been done in terms of gender issues in computing and technology has indicated that in grade 7, the interest in computing technology is equal by both, you know, between boys and girls. By grade 10, the girls are out of it. So if your granddaughter's in grade 5, she's got a good 2 years left before she may go down a slippery slope to, I don't know, social work. Anyway, so Daryl has brought a cake up here. I understand that the rules are, since we can't eat or drink in this room, we're going to have a ceremonial cutting of the cake. Then we're going to get outside to the rotunda and say hello to old friends and have some nibblies, including the cake, right?
So I have some gifts, so you can have a seat on the hot seat there. So I have some gifts for presenters, so please join me in thanking all of our guests. So I have a picture of the campus. Surprise, a picture of the campus.
Say, right there. When I started here, this was all mud.
ask each of our panelists to pick a name, and you have to be here to get the prize. Okay, Jackie Chen. No, well, not as far as I know. It's Jackie Chen? No? I feel like I'm participating in some kind of punchline now. Mohammed Mohudin? I'm sorry for that pronunciation. Mohammed? Mohiuddin? Okay. We have more cards here.
No one's going to ask for photo ID, so.
Brad Bright. He's teacher and also an alumnus of the department. Okay. Next panelist. Grant Gilchrist. What a way to take attendance. Raymond Arscott. Taco Science t-shirt. Rajesh Patel. Going once. Rajesh Patel. Not present. Okay.
Keep them both out.
Oh, Shelby. Shelby's a recent graduate of the bachelor's program and starting his master's. Thank you.
It all worked out then.
And our last prize is Donna's book. It's going to be autographed if not already.
Susan McGilvery, are you here? All right. Yes.
Congratulations.
Okay.
So would you let... Oh. So maybe I'll call on Brian to help me cut the cake. I don't know if we need to sing happy birthday. But...
Okay, before we do that, and just quickly, I'd like everyone to put your hands together and thank Daryl for all the work he's done on this. It doesn't take two of us to do. I'll hand you the knife. There.
Okay. There we go. Now, if anyone asks if you didn't eat this in here, we're going to take it outside and eat it outside.
embarrassing or otherwise, whatever, of people sleeping in labs in class, anything to do. Anyway, post us anything that we can use to put together some memories of what's happened around the department. And I won't say over the last 50 years because I'd be pushing that, wouldn't I?